Hey everyone, today we're solving AS Physics 9702, paper 1-3, May-June 2022. This is the last paper in the May-June 2022 series for physics. Sorry for the long hiatus, I was quite busy. After this, I have plans to do paper 5 for physics and chemistry and paper 1 for biology, right? Since you have those exams coming up in the next month. The October-November series, right? So this should be good practice. So let's talk about the threshold before we begin. So here for paper 1-3, the maximum mark was 40, 25 was A, 21 was B, 18 was C, 15 was D, and 12 was E. Alright, it's pretty hard to get an E if you practice properly. So basically the cutoff mark for B was 21, around 50% of the marks, and 25 was an A, so it was quite a difficult variant, it seems. So A star should be probably at around 30 to 32 approximately. All right, it isn't shown in the threshold, but it should be around there. All right, let's begin. Which pair of quantities are physical quantities? So a physical quantity needs a value as well as a unit. Okay, so charge and ampere. Ampere is a unit. It is not a quantity, so it is wrong. Efficiency and kilogram. Kilogram is also a unit. And efficiency is actually a ratio. It doesn't have a unit, so it's wrong as well. Pascal is a unit, so it won't work. Period. The unit is second. And potential difference, the unit is volts. So these are in fact quantities. One is D. Let's go to 2. To which list of unit prefixes decreases in magnitude from left to right? Okay, so let's think about it. Centi is 10 to the power minus 2 meters. So it's like this, right? This is meter, 10 power 0. So this is kilometer, megameter, 10 power 6, 10 to the power 3. We have millimeter at 10 power minus 3, micrometer at 10 to the power minus 6, yeah? So where is centimeter located? cm is over here at 10 to the power minus 2. And decimeter is at dm cube. You know that from chemistry. That's 10 to the power minus 1. So 10 power minus 1, 10 power minus 3. So it is not decreasing in magnitude from left to right because deci is the greatest one. So A is wrong. So 10 to the power minus 1, 10 power minus 3, 10 to the power minus 2. Wrong again. 10 to the power minus 12, 10 to the power 3, 10 power minus 3. This doesn't make sense, yeah? 10 power 3, this is huge. This is smaller, and this is much smaller. Pico is 10 to the power minus 12, by the way, guys. So the answer is D again. 3. The drag coefficient. CD is a number with no units. It is used to compare the drag on different cars at different speeds. CD is given by the equation, where F is the drag force on the car, rho is the density of the air, A is the cross-section area of the car, and V is the speed of the car. What is the value of N? Okay, so CD has no units. Basically, there are no units on this side. This equation has to be homogeneous, right? It has to be homogeneous. So let's try doing it. F is the force, right? So we're gonna exclude the values, by the way. So no unit on the left hand side, so no units on the right hand side. F is the force, so that's kg ms minus 2. That's the force. Velocity is meter per second to the power n. Rho is kilogram per meter cube, and A is cross-sectional area, that's meter square. Okay, so if we do simplify this, we end up with kg ms minus 2, that's force, mass times acceleration, divided by ms minus 1 to the power n times kg meter to the power minus 1. Okay, so we can in fact get rid of these kgs, and if you do equate this or simplify this, you end up with meter square is minus 2, m is minus 1 to the power n. So n clearly has to be 2 to balance things out, right? So yeah, 3 is B. 4. A micrometer screw gauge is used to measure the diameter of a small uniform steel sphere. The measurement of the diameter is 5 millimeter plus minus 1 0.01. What is the percentage uncertainty in the calculated volume of the sphere using these values? Okay, so V is equal to 4 by 3 pi r cubed for a sphere. So 4 by 3 pi, those are constants, we're going to ignore them. So del V by V into 100 is equal to del R by R into 3 times 100. Why the into 3 though? Basically because it's R cubed, right? So we have to consider R thrice. Okay, so take your calculator. It is going to be, oh, by the way, this is diameter, right? So I can't really use this formula. I can't really use this. What do we need to go for? We should go for V is equal to 4 by 3 pi d by 2 whole cube. So that's basically 4 pi d cube divided by 2 cube is 8. 8 times 3 is 24. That's 1 by 6 pi d cube. That doesn't really matter. It's still, it's still del V by V into 100 is equal to 3 del D by D into 100. Same thing, right? So 3 times 0.01 by 5.00 into 100. So 3 times 0.01 divided by 5 into 100. That gives us a value of 0.6. So it should be 0.6% if I'm not wrong. And yeah, the answer to 4 is C. Forces of magnitudes 2, 4, and 7 combine to produce a resultant force. The magnitudes of the three forces are fixed, but the forces may act in any direction in the same plane. What is not a possible magnitude of the resultant force? Okay. Magnitudes are fixed, but they may act in any direction on a certain plane, which is not possible. All right. So basically, guys, look at this. If 7 is pointing in this direction, and 2 and 4 are pointing in this direction, right? Whoa. 2 and 4 are pointing in this direction. 2 plus 4 is equal to 6. The resultant force needs to be 1 at least. This is the minimum force possible. You can't get a force lower than this. Could I clarify? So 1 is your minimum value of force. You can never get 0. That is how I can conclude this. I won't even bother checking B, C, and D, because 0 isn't possible in any way. If it was 3 and 4, yeah, that would be fine. That would totally be okay. But it's not possible here, okay? How can you get 13, by the way, if you add all of them up, right? So that's another probability. Like, guys, if this was 1, this would not be the answer. But if this was 12, this would definitely be the answer, because 7 plus 4 plus 2. Actually, we're not sure about that. The minimum one is a better alternative, yeah? So the minimum force is 1. We can't go below this. So the answer has to be A. 0 is not possible. Number 5. Two projectiles X and Y. I had this done actually. My students asked me to do this for them. Two projectiles X and Y are fired into the air from the same place on level ground and reach the same maximum height as shown. So let's think about these particles. X is only moving vertically. X is only moving vertically, whereas Y also has a horizontal component. Air resistance is negligible. Projectile X is fired vertically upwards and projectile Y is fired at an angle to the horizontal. If you check it properly, you're gonna see that they reach the same maximum height. What does that mean? That means since there's no air resistance, the only force acting on them is gravity, right? And they reach the same height. What does that mean? if you look at this, v square is equal to u square plus 2s. At the final height, velocity becomes 0, u square minus 2gs, or 2gs is equal to u square. So since s is the same, s is equal to u square divided by 2g for both of them. G is constant for both of them. 2 is also a constant. What does that mean? U represents initial vertical velocity. So initial vertical velocity is actually the same for both of them. Okay, and due to the initial vertical velocity being the same, check this out, v is equal to u plus at. So 0 is equal to u minus gt, or gt is equal to u, or t is equal to u by g. That's the time taken to reach the maximum height, and the time taken to reach the ground will be twice this. Time taken to reach the ground will be twice that value, and it will be the same for both of them. Okay, so their initial velocity is the same, their initial vertical velocity, I mean, and the time taken to reach the ground is the same, and the time taken to reach the maximum height. So x and y are at rest at their maximum heights. This is wrong because y still has a horizontal component over here. X and y are fired with the same speed. Wrong. They have the same vertical speed, but y does not have the same vertical speed. Has the same vertical speed, but not the same speed, because speed has two components, horizontal and vertical. So since y has both horizontal and vertical components, its speed is actually greater than that of x. Okay, x and y take the same time to reach the ground. That is correct. X and y travel the same distance. Wrong. This is wrong because x only travels a vertical path up and down, but y is traveling a curved path that can never be the same. Okay, so D is also wrong. 7. Okay, so a few people had problems with 7 as well. A small glider moves along a horizontal air track as shown. At each end of the air track, the glider has a perfectly elastic collision with a fixed buffer. So elastic collision means that no velocity will be lost. Which graph represents the variation with time t of the velocity of the glider as it moves between the two buffers? The glider moves at a constant speed between collisions. Okay. So it is not losing velocity as it hits the buffer, and it is not losing velocity as it moves in between the buffers. Very important. Okay. So let's see. Let's look at the graphs. It can't be A because in what's wrong with option A? It looks as if that, suppose when it starts moving, yeah, the first collision it's elastic, but in the second collision it seems as it looks as if it lost velocity. That's not possible. B is wrong as well for multiple reasons. There's that reason, and the areas are not the same. Also, the distance moved between these two buffers will be the same, so these areas, the areas under the graph, need to be the same. Okay, so look at C. What's wrong with C? C is fine up till this point, but what happens here? The velocity remains the same, yeah, but these areas don't remain the same anymore. Do you guys get the issue? Let's move on to the next one. D is perfect. Velocity remains the same as well as the distance covered. Okay, the area under the velocity time graph represents the distance. Do you guys understand? This is very important. So since elastic collisions, these heights have to be the same. It's a must, which is why A and B are wrong. And why D over C? Because the distance, the area under the curve also has to be the same, because this represents, suppose you're moving from left to right, this is this area. Now you're moving from right to left, this is the next area over here. So it keeps on repeating. Get it? Number 8, a car accelerates from rest. The graph shows the variation of the momentum time graph. So guys, remember, force is equal to the rate of change of momentum. That's the definition of force and Newton's second law, right? So what does the gradient of the graph represent? It's actually the resultant force on the car, right? So it's actually C. Clear? 9. A ball is dropped onto horizontal ground and bounces vertically upwards. When the ball is in contact with the ground, the following forces act: the weight of the ball, the contact force P exerted on the ground by the ball, and the contact force N exerted on the ball. Okay, so P is on the ground by the ball and N is on the ball by the ground. When the ball is in contact with the ground, the ball is momentarily at rest. At this instant, which relationship is correct? Okay, so N and P are contact forces, okay? N and P are contact forces. You guys need to understand that. Okay, N and P are contact forces, and the pair forces, I mean, and the pair force of weight is actually, suppose, since W is the weight of the ball, that means the earth is pulling the ball is also pulling the earth. That's the red arrow I've shown you, okay? So N is actually equal to P, and W is equal to, sorry, is equal to the red arrow, but we don't have those options over here, okay? So that's a no-go. N is equal to P plus W. N is equal to P plus W. This is impossible, guys. Come on. I just told you that N has to be equal to P. How can N be equal to P plus W? Wrong. Next, N is greater than P plus W. Interesting. N is greater than W and N is equal to W. So these are our remaining options. So here's the thing. N is equal to P. So if you write it like this, N minus P is greater than W, it's gonna end up as N minus P is 0, 0 is greater than W, so B can't be right as well, okay? Since N is equal to P, they're pair forces. Now N is equal to W and N is greater than W. Let's check this out properly. So here, um, a ball is dropped onto horizontal ground and bounces vertically upwards, okay? It bounces vertically upwards. That means clearly, since it's going to bounce up in any moment now, it's going to, get a force from the ground. Weight is obviously going to act downwards all the time. If it was stationary, okay, if it was stationary, if it was not moving, like, yes, I do agree it is momentarily stationary, but that doesn't indicate what's going to happen in the future. It might move in the future, right? So even if it's momentarily at rest, it's not in equilibrium. If it was in equilibrium, it wouldn't have bounced. Then N would also have been equal to weight. That would be C then. But here, they told us that it's going to bounce vertically upwards. So there, it's not in equilibrium, and the force from below N must be greater than the force that's going downwards. So N must be greater than W, since the ball is bouncing upwards. This is what you guys need to understand. And if it remained at rest, if it did not bounce, then N would be equal to W, okay? A bit tricky. Number 10, a person stands on the edge of a high cliff that is next to the sea. The person throws a stone vertically upwards. A resistance acts on the stone. Which velocity time graph best shows the motion of the stone from when it is released until it hits the sea? So the person is on the cliff and he throws the stone vertically upwards. Air resistance acts on the stone. Okay, so it's gonna go up and then it's gonna go down until it hits the sea. So when it's going up, guys, think about it. It is experiencing weight plus air resistance downwards, and it's gonna reach a maximum height. Okay, so it is going up initially. It is going up before it goes down. It goes up before it goes down. Okay. So what's wrong with A? It can't be A. Okay, it can't be a straight line because air resistance is acting. If air resistance was not acting, this was a possibility. So the line has to be curved. That's the first thing, since air resistance acts on the stone. Now what? At a certain time, at maximum height, you guys know what happens to velocity. Velocity will be equal to 0. So we need a point on the graph where velocity equals to 0. C can't be the answer because we had initial velocity, but at the midpoint velocity was not equal to 0. Do you guys get it? It actually hit 0 when it hit the C, but it should also hit 0. And we don't know if it's gonna be 0 when it hits the C. It might still go downwards, right? So C is wrong. It's between B and D because in both these cases, we have a certain time at which velocity does reach 0. So why not D? Why am I gonna exclude D? Look at this. So at first we are going up. Okay, so going up might be a positive velocity. It is a positive velocity here. So we are going up, we're going up, going up, and we are decelerating. Okay, we are going up and we are decelerating, and what at one point we reach 0 velocity, and then we're supposed to go down. So since I've assumed that going up is a positive velocity, going down must be a negative velocity. But check this out. Here they're saying that going up is also a positive velocity and going down is also a positive velocity. That doesn't make sense. This part of the graph should have been down below. That's the issue with this. It's not down below. It should have been like this. Then it was a possible candidate. Do you get it? It can't be a reflection. Because how can going down and going up be a positive velocity? They need to change directions. That's why B is the perfect answer. Check this out. Why is this perfect? Okay, so at first we had some velocity, and that means going up is actually negative and going down is positive. Going up is actually negative. So we are going up at first, and that's a negative velocity. And at one point we reach a value of 0. That's our maximum point over here. So what is this area under the curve? It represents the height we traveled while we went up. The height we traveled while we went up. By the way, what is this area under the graph? This represents the distance we travel from the maximum height to the C actually. Okay, we are talking about this height as a whole. And look at this. From this part to this part, we actually had a negative velocity, which meant we were going up. And after this point, we have a positive velocity, which means that we are going down. Now that makes sense. Okay, do you guys understand why the others are wrong? C, A is a straight line, that's wrong. C does not have a point at the middle where velocity is 0. D is a reflection, and B is the correct answer. Okay, let's move on to 11. Skaters of mass 80 kg and 40 kg move directly towards each other and collide. Before the collision, the heavier skater is moving to the right at a speed of 2 meters per second, and the lighter skater is moving to the left at a speed of 1 meter per second. After the collision, the heavier skater moves to the right at a speed of 0.8. Where is the relative speed of separation of the two skaters? Okay, guys, so heavier skater is moving to the right. Okay, 2, 1. After the collision, this is BC before collision. After collision, the heavier skater moves to the right again with a speed of 0.8. What happens to this guy? We don't know. Okay, so what's the momentum before collision? Actually, 80 times 2 minus 40 times 1, which is 160 minus 40, which is actually 120. Okay, so it has to be 120 over here as well. So here it's actually 80 times 0.8 plus 40 times the velocity. I don't know the direction of the velocity, but it has to be equal to 120. Yeah, so 80 times 0.8, 120 minus answer divided by 40 gives us an answer of 1.4. So V is equal to 1.4 meter per second. Okay, so that's the answer. No, wait. That's not the answer because this is the velocity. I'm getting a positive velocity of plus 1.4. And since I consider right side to be the positive, this skater, the lighter skater, is moving with a velocity of 1.4 to the right hand side. So this is the velocity of the lighter skater. Now, if we want to find out the relative speed of separation, if you are moving in the same direction, you need to subtract. So it's going to be 1.4 minus zero point 0.8, which is 0.60. 11 should be A. Okay, remember that. Which statement describes the two forces in a couple? They act, this is a couple, acting in opposite directions, same magnitude. Okay, so same direction, wrong. Act through the same point, no. There's no guarantee. They produce zero resultant force. This is true. But they do produce moment, but they do not produce a resultant force. Okay, they have turning effect. Okay, let's go to the next one. A street lamp is fixed to a wall by a metal rod and a cable. Great. It's glitching out. Wait. So guys, clearly we want to find out the vector triangle. Okay, we want to find out the vector triangle. So let's see. By the way, they say that it's held in place. This is the keyword. It's fixed. That means the system is in equilibrium. For a vector triangle to be in equilibrium, we must get a closed triangle of forces. That means all the heads of the arrows must point to the tails. This head must point to the tail. A looks like an option. B does not look like an option. C does not look like an option because this head is pointing towards this head. It's between A and D. Now let's look at this. The lamp, right? It has a weight which is acting downwards. Now this has to be fixed. This cable has a tension which is acting in this direction. Clearly. So the weight has to be vertically down. There can't be any component that is acting vertical upwards. Or basically you need a vertically downwards component. Now look at this. That's why D is the best option. Because we have a vertically downward component. In A, we don't have that. That's why A is wrong. It has to be D. It's because of this arrow. This is the wrong arrow. So this is the tension essentially, and I guess this is the reaction force that the wall provides to the metal rod. Could I clarify? Check if you get this, okay? 14. An unknown mass and a 1 kg mass are fixed at opposite ends of a bar. The bar has negligible mass and a length of 30 centimeter. The bar balances when supported by a pivot placed 20 centimeters from the unknown mass as shown. Okay, what is the unknown mass? Okay, what's the weight of the bar? Oh, the bar has negligible mass. Okay, so we don't need to consider that. Isn't this too easy, guys? Come on. So this has to be 10 centimeter, right? So basically, you guys are saying 10 times 1000 grams. Okay, let's convert it to grams. 1 kg is 1000 grams is equal to unknown mass. Okay, let me do it the correct way. Fine. Clockwise moment is equal to anti-clockwise moment. So this is the clockwise moment. So that's 1 into 9.81 into the distance, which is 0.10. Actually, you don't need to convert it to meters because both of them are centimeters, is equal to 20 times weight, which is 9.81 into mass. Let's find out the mass, right? We can get rid of 9.81. 10 divided by 20, that's 0.5. The mass is 0.5 kg, which is actually equal to 500 grams. We good? A block of density rho W has sides of length A. The block is immersed in a liquid of density rho L. The top surface of the block is at a depth h below the surface of the liquid. The acceleration of free fall is g. What is the upthrust acting on the block from the liquid? So remember, the formula for upthrust is v rho g, guys. It's v rho g. Do you guys understand? Where rho is the density of the fluid you're in. Okay, not the density of the block, but the fluid. So it's gonna be rho L liquid times G times the volume. Since this is a cube, it should be a cube. So a cube rho Lg. A cube rho Lg. We should go with 15a. Get it? They just gave you this rho W to 3q. A technical article about diesel engines, what diesel engines expresses the energy available from diesel fuel, both as 41.8 megajoule per kg and as 34.9 gigajoule per meter cube. What is the density of diesel fuel? Okay, okay. So one of them is 41.8 megajoules per kg. Another one is 34.9 gigajoule per meter cube. So we want the density. So somehow I want kilogram per meter cube. Somehow I just want kilogram per meter cube. Okay. So what if I write 34.9 gigajoule per meter cube divided by 41.8 megajoule per kg? What's going to happen to this? 34.9 into 10 to the power 9 joule per meter cube divided by 41.8 into 10 power 6 joule per kg. What's up here? We can get rid of joules, and after reciprocal we are actually going to end up with, wait, 34.9 into 10 to the power 9 divided by 41 point into 10 to the power 6, yeah, 834.9. This is 834.9 kg per meter cube due to the reciprocal of kg. So 834.9, which is 8.35. 8.35 into 10 power minus 2. 8.35, sorry, into 10 power 2 plus 2. So yeah, I'm gonna go with 16A. What is meant by the efficiency of the system? It's basically useful power divided by total power, useful power output by total power input into 100. Or just the ratio. Look at C, the ratio of useful power output to the total energy input. That is the best way of wording it, okay? The others are wrong. I'm just looking for the correct one over here. 18. A car of weight 15,000 newtons is traveling along a horizontal road. At one instant, whenever they use this wording, you need to realize that they want you to use P is equal to Fv. The thrust force acting on the car from the engine is 12k and the resistive force acting on the car is 3k. The velocity of the car at this instant is 24 meter per second. So we can use P is equal to Fv, okay? So what is the power output from the engine? So guys, remember that in P is equal to Fv, the F is actually the driving force. Clear? So we are going to use P is equal to Fv. So P is equal to driving force into velocity. So we want to find out the power, right? So it's just going to be, wait, let me show you. I just made it a bit complicated over here. So why don't we just go for the power is 12,000 times 24. Let's see how that goes. 12,000 times 24. That's 288k. The closest answer is 290 kilowatts, right? So it's 18C. So they just gave you 3000 to trick you. But remember, for output power from the engine, you're just going to use the thrust force. If they said what's the useful output power, then you'd subtract it, okay? But they didn't want the useful output power. They wanted the total power output from the engine. So not all of it is going to be useful work, okay? 19. The diagram shows the variation of a quantity y with a quantity x for objects in a uniform gravitational field. What could x and y represent? Mass and Ke. This is not possible. K is equal to half mv square. Kinetic energy and mass have a linear relationship, so 19a cannot be right. Ke and velocity, what's the relationship? Ke is actually proportional to v square, right? So remember the graph y is equal to x square. What does it look like? If you plot a graph of y against x, doesn't it look like this? So yeah, this is actually correct. If this is k, this is y, and this is velocity, of course it's going to be a u-shaped graph. Perfect. But if it was the square of the speed, on the x-axis and the kinetic energy on the y-axis, it would have been a straight line. Okay, you guys need to understand that. 20. A steel wire has a length of 300 centimeters and a cross-section area of 0.5 millimeters square. The Young modulus of steel is 2 into 10 power 11 pascals. One end of the wire is attached to a fixed point. A load of 10 newtons is hung from the other end. The wire obeys Hooke's law. What's the extension of the wire? Okay, so you know that E is equal to FL by AE. So small e is equal to FL by A capital E. So what's the weight? 10. The length is 300 centimeter, or that's brain freeze, by 100, right? 3 meters. Divide by area. Oh, we have the area. It's 0.50. So 10 power minus 3 whole square, which is 10 to the power minus 6 millimeter square to meter square, times 2 into 10 to the power 11. Okay, so let's find this out. I actually had exams the last 2 weeks, so I couldn't bring out any videos. I couldn't bring out paper 2 videos, sadly, for physics and chemistry. I have a break right now, so hopefully I can record a lot of videos. You have paper 5 and paper 1 with exams coming up, right? So I'm going to try to do that. And if you like the content, please do subscribe to the channel. It would help me a lot. The percentage has increased. It's around 15% of you are subscribed to the channel. But please do if you haven't already, alright? Thank you. So 0.5 times 10 to the power minus 6 times 2 into 10 to the power 11. That's 3 into 10 power minus 4. So I'm gonna go with C. Okay, 21. The extension of a copper wire is measured for different forces applied to the wire. A graph is plotted to show the variation of the force on the wire against extension. The maximum force is applied at point P. Which statement must be correct? Okay, guys. Till S, the limit of proportionality is maintained. Point R is the limit of proportionality. Impossible. S might be the limit of proportionality. The elastic potential change of the wire at point S is given by the area under the graph between points T and S. This is an fx graph. Please check that. If it was an xf graph, it would have been different. This is an fx graph. So yeah, this seems okay. This is okay. There is no plastic deformation between Q and P. We don't know that. We don't know the elastic limit. We don't know where the elastic limit is. Okay. That's why we can't say. The wire obeys Hooke's law up to a point between R and Q. No, up to S. 22. Finally, waves. The variation with distance x of the displacement y of a transverse wave on a rope is shown at time 0. The wave has frequency 0.5 Hertz. A point P on the rope is marked. The diagram shows the original position of P and 4 new positions. What is the position of P at time 1 second? So guys, this was a trick question. Remember, in a transverse wave, the particles themselves don't move. Energy is propagated, but the particle does move, but only vertically, perpendicular to the direction of energy propagation. It only moves up and down here, not right and left. So C and D are wrong. The particle will either move up and down, but the energy will be progressed or transferred to the right hand side. So here's the thing, the frequency is, guys, F is 0.5 Hertz. You guys know that F is equal to 1 by T, okay? So time is equal to 1 by F, or 1 by 0.5, or 1 by half is actually 2 seconds, right? The time period is in fact 2 seconds. So after 2 seconds, P is going to come back to the original position over here. So you're always going to break down the time period into 4 parts. So 2 divided by 4 is actually 0.5. So after 0.5 seconds, you're going to travel a quarter of the distance. What does that mean? After 0.5 seconds, you're going to go to A. After another 0.5 seconds, you're going to go to B. After another 0.5, you're going to come back to A. After another 0.5, you're going to come back to P. So where is P going to be after 1 second? So the first 0.5, we're going to go to A. The second 0.5, we're going to go to B. B should be your answer. 22 should be B. And if they said 2 seconds, the answer would have been B. Like we'd return back here. And C and D would never be the answer. If they said 0.5 second, the answer would be A. If they said 1.5 seconds, the answer would again be A. Hopefully you guys get what I mean. This should have been covered in stationary waves when you were doing it. Okay. Please do comment below if you don't understand. I'll try to give a better explanation. Which property of sound is measured using only information from the CRO? So we have the time base and the Y gain in the CRO. So the time base actually gives us an idea about the time period. Which property of sound is measured using only information from the CRO? So we can find out this, then we can find out the time period. Like if we know the time base and multiply it with those boxes, we can get out the time period. And if we know this and multiply it with the Y gain, we can find out the amplitude. So it's not C and D, clearly. It's not C and D, it's between A and B. So here's the thing. The answer should be B, because the x-axis is literally called the time base. So if you multiply the number of boxes with the time base, you get the time period directly. But the y-axis is actually the voltage gain. It actually gives us the voltage rather than the amplitude. We use it as the amplitude, but it is not exactly the voltage. I mean the amplitude. So yeah, using information from the CRO, we can get the time period directly. This is the important thing. Okay, you guys need to understand that. But we can find out the amplitude eventually. We can get a voltage, and using that we can go further. 24. A transverse wave and a longitudinal wave both travel in the same direction down a long stretch string. Which statement is not correct for these two forms of waves? The displacement measurements for the particles of the two waves are made at right angles to each other. It is made, the displacement for the transverse wave, okay, for the transverse wave is made at right angles. Oh, to each other. They're talking about to each other, right? So suppose if this is the spring, I draw so bad diagram. So suppose this is a spring, sorry. This is a rarefaction. This is a compression again. This is a rarefaction. So for the longitudinal wave, the displacement will be measured in this axis, and for the transverse wave, the displacement will be measured in this axis. So yeah, they are right angles to each other. This is correct. The energy transferred by the two waves is in the same direction. That is true. Energy is always transferred like this, suppose to the right. The Why did I circle A? My bad. So A is correct, B is also correct. C. The velocities of the two waves are in the same direction. Right, both of them are moving to the right. Okay. The velocity of the wave actually represents the direction of energy propagation, not the displacement. Displacement only determines amplitude. Okay. For the longitudinal wave, it is the same direction as the direction of energy propagation, but for the transverse wave, it is perpendicular to it. Okay. So that is why they are measured at right angles to each other. D. The wavelength measured for the two waves are made at right angles to each other. Not really, not really. Look at this. For the transverse wave, we do it like this. Okay, we do it like this. From one crest to another crest, okay? For the longitudinal wave, it is also from one compression to another compression. So they are not at right angles to each other, okay? They are parallel to each other. That is why D is wrong. It was tricky in a sense, yeah? 25, Doppler effect. A man standing next to a stationary train hears sound of frequency 400 Hz emitted from the train's horn. The train then moves directly away from the man and sounds its horn when it has a speed of 50. So when something is going away from you, wavelength increases and frequency decreases. Okay? Wavelength increases and frequency decreases. So initially, the man was standing next to the train, so there was no Doppler effect. Now the train is going away from him. So remember that the observed frequency is equal to the frequency of the source multiplied by the velocity of the sound itself, or the wave, divided by the velocity of the sound plus minus the velocity of the source. So the observed frequency will be equal to 400, the source frequency, times the velocity of sound 340 divided by 340. Now you have to pick the plus minus sign depending on the instance, the scenario. Since the object is actually going away from you, the wavelength increases and frequency decreases. So to decrease the frequency, you need to increase the denominator. You're going to go for plus 50. Okay, this should work. Let's go for it. 400 times 340 divided by 390. We're getting an answer of 348.72. 348.72. So guys, basically this is the new frequency, and what was the old one? It was 400. So what's the difference between these two instances? That's what they want, the difference. It's actually 51 hertz. Yeah, 25 is A. Next, which list of regions of the electromagnetic spectrum is in order of increasing wavelength? Okay, so remember GX, UV, IMR. Just memorize this. GX, UV, IMR. This is increasing wavelength or basically decreasing frequency. So, is in order of increasing wavelength from left to right. So, gamma, that's right. Ultraviolet, G, U, I. Guys, I guess we have a winner. 26 is A. 27. The principle of superposition states that a certain quantity is added when two or more waves meet at a point. What is this quantity? Okay, so a lot of rookie students would mark amplitude, but it's displacement. Displacement is added. Amplitude is the ability to reach maximum. It's the maximum displacement from the point. Not necessarily will it always be added. Some displacements might be added, like a graph like this. What if it's like this? These are not amplitudes, but they'll still be added. They're displacements. Okay, 27 is B. Okay, so for 28, what do we have? A station wave is formed in a gas-filled tube of length L, which is closed at one end by a piston. The length of the tube can be altered by moving the piston. The length of the tube and the frequency of the sound are varied so that the station wave always has two antinodes and two nodes. Okay. The graph shows the variation of the frequency of the stationary sound wave with the length L of the tube. What is the speed of sound in the gas in the tube? Interesting. So guys, let's see how to do this. Essentially, this is an antinode, this is a node, antinode, node. So you guys know that from an antinode to node, it's lambda by 4. From an antinode to antinode, it's actually lambda by 2. And this is lambda by 4. So in total, it's actually 3 lambda by 4. This is the total one, okay? Now, that's the total distance in terms of lambda. Now we need to pick a suitable value. Okay, we gotta pick a suitable value. Let's see. How about 2500? Is this a good value? Probably. Matches with 9. So frequency 2500 and length 9 cm. So V is equal to, so that's the length of the tube. Okay, so we know that L is equal to 3 lambda by 4. I just taught you. So lambda is equal to 4 times 9 centimeter, which is 0.09 meter, divided by 3. Let's find that out. 0.09 by 3 into 4, that's 0.12 meters. So what's the velocity? V is equal to F lambda, which is 0.12 times 2500. Let's go for it. I'm getting a value of 300, exactly 300. It should honestly be C, and yeah, I'm right. Number 29. The diagram shows the diffraction of water waves in a ripple tank as they pass through gap. Which diagram is correct? So for ideal diffraction to take place, the gap should be smaller than the wavelength. And after diffraction, wavelength cannot change. That means this distance needs to remain constant. A is wrong that for that reason, because the distance for just changes. C is also wrong. Check this out. It's so small, but it becomes much greater. A and C are wrong. So between B and D. Oh, for D it's the same. The distance becomes smaller. For B, the distance remains the same. So B is the answer. Okay, 29 is B. 30. A beam of light from a laser is incident normally on a double slit. Interference fringes are seen on a screen placed parallel to the double slit. The separation of the two slits is A. The distance between the slits and the screen is D. The distance between the centers of two adjacent bright fringes is X. D and A are both halved. What is the distance between the center of the two adjacent bright fringes after these changes? So we have a double slit. The formula for the double slit is X is equal to lambda D by A. Okay. So D and A are both halved. So X is equal to lambda into D is halved, A is also halved. So these two, we can get rid of them. We end up with X is equal to lambda D by A. So it actually remains the same. It was just a trick question. 30 is B. 31. A beam of light of wavelength 400 nanometer is incident normally on a diffraction grating that has 300 lines per millimeter. The light passes through the grating and produces a series of maxima which are observed on a semicircular screen as shown. What is the total number of maxima observed? Okay, so to find out the maximum number of maxima, we gotta go for this formula. D sine theta is equal to n lambda. Okay. So let's write it down. We have 300 lines per millimeter. 300 lines per millimeter. Okay. So let's go for it. I'm gonna input sine 90. So you gotta use 90 degrees, okay, to find out the maximum number of maxima on one side basically. And what's the value of D? This is actually capital N. D is actually 1 by N, okay? D is equal to 1 by N, so 1 by 300. That's 3.33 into 10 to the power minus 3 millimeter. Let's convert it to meters into 10 to the power minus 3. So that's 3.33 into 10 to the power minus 6 meter. So 3.33 into 10 to the power minus 6 meters into sine 90 is equal to n times lambda. 400 into 10 to the power minus 9. Okay. So let's go for it. Into sine 90, which is 1, divided by 400 into 10 to the power minus 9, which gives us an answer of n is equal to 8.33. So we can't take 9, it has to be 8. So 8 on one side, 8 on the other side, and 1 over here. How much is that in total? 16 plus 1, which is 17. 31 is D. Two wires X and Y are made from the same material. Okay. That means number density is the same. The diameter of Y is twice that of diameter X, wire X, wire Y, and the battery are connected in series. That means the current is the same. So we know that I is equal to NAVQ, or V is equal to I divided by NAQ, essentially. Yeah. So V of X divided by V of Y. What is that exactly? I divided by NAXQ divided by I divided by NAYQ. Here's the thing, they are in series, so I is the same. They're of the same material, so N is the same, and Q is the same, it's the elementary charge. So if you do deal with this properly, 1 divided by AX divided by 1 divided by AY. If you do the reciprocal properly, you're going to end up with AY divided by AX. Okay, so Y has a diameter that is twice. So it's going to be pi into 2d by 2 whole square divided by pi into d by 2 whole square. We can get rid of pi and the 2 over here. So we end up with d square divided by d square by 4. So if you reciprocal, it's 4 and get rid of the d's. So the answer should be 4 by 1. Logically, 32 is D. Okay. Next, a resistor has resistance R. When the potential difference. Do you need to see the working on the right? Check it if you need it. 33. A resistor has resistance R when the potential difference across the resistor is V. The current in the resistor is I. The power dissipated in the resistor is P. Work W is done when charge Q flows through the resistor. What is not a valid relationship between these variables? Okay, so guys, P is equal to IV. This matches. A is right. Uh, Voltage is equal to work done by charge. We can get that through here. This is right. P is equal to I square R. That is another one. P is equal to V by R. This is wrong. It is supposed to be V. P is equal to V square by R. Okay? Does that make sense? Great. 34. A fixed resistor and a filament lamp are connected in series to a power supply. The IV characteristics for the two components are shown. By the way, guys, we just hit 2,000 subscribers after the last video. I'm really happy about this. I plan to reach around 3,000 subs at the end of this year, and let's see how next year goes. Depending on the output I receive from you guys, you're gonna get more videos. So please support the channel, right? So a fixed resistor and a filament lamp are connected in series to a power supply. The IV characteristics for the two components are shown. Okay. The current in the fixed resistor is 0.34 amps. Where is the resistance of the filament lamp? They are connected in series. Okay, so since they're in series, the current flowing through them is the same. So 0.34, it's over here. 4.2 basically. V is 4.2. Okay. This is 34, right? So the voltage is 4.2. The current is 0.34. The resistance should be V by I, which is 4.2 by 0.34. I'm getting an answer of 12.4 ohms. So what's the closest answer? It's B. Okay, 34 is B. Okay, 35. A piece of conducting putty, or it's not putty, right? Or is it? So a piece of conducting putty, which is apparently modeling clay of constant resistivity, is formed into a cylindrical shape. The resistance R between its flat ends shaded is measured. The same volume of putty, I feel like I'm making a mistake for some reason, is reformed into cylinders of different lengths L, and the resistance R between the flat ends is measured for each value of L. Which graph shows the variation of R with L? Alright. I didn't get the question. A piece of material of constant resistivity is formed into a cylindrical shape. Okay. We know that R is equal to rho L by A. That's the formula. The same volume of putty is reformed into cylinders of different lengths L. And the resistance R between the flat ends is measured for each value of L. Okay. So they are of the same material. So rho is the same for all of them. Okay, rho is the same for all of them. We know that R is equal to rho L by A. So R is actually proportional to L, but inversely proportional to the area. Now, the key part is the same volume of putty is reformed. So we know that the formula volume is volume equals to cross-sectional area into length. Okay? Cross-sectional area into length. So here's the thing. So suppose this same volume, right? This cross-section area and length, this same volume is reformed into cylinders of different lengths. So for example, if we have a small value of length, we need a greater value of area to compensate. Similarly, to keep the volume constant, if the length becomes really high, suppose we have a really long, putty, so the area needs to be really small to compensate, or else the volume will never be the same. You can't increase both at the same time. If you decrease one, you gotta increase the other, and vice versa. Okay, so guys, think about it. Let's consider object 1, the one which has very low length. Okay, so when you have low length but really high area, what happens to resistance? Low length but high area, numerator decreases, denominator increases, resistance also decreases. So for a low length, remember, for low length, resistance should be low. Next, for high length. So for high length, we know that R is proportional to L by A. L should be high and A should be low. So numerator increases and denominator decreases. So R actually increases by a lot. It should be very high. So high length, since area decreases, R must decrease exponentially basically. So it can't be a straight line. You guys need to understand that. It can't be a straight line. Okay. And at low resistance, I mean low length, you have low resistance, but at high length you have high resistance. It matches with D. It can't be A because it never remains constant. It's not a straight line relationship. It's between C and D, and D matches the criteria. C is wrong in which sense? It's the opposite of what I just tried to explain to you guys. Okay, so yeah, this was a challenging MCQ. Many people would have messed this up while solving it. Hopefully you guys understand it now. The main thing is we reformed it into a different material, but we kept this volume the same. So if you increase L, you have to decrease A. If you decrease L, you have to increase A. Okay. So the diagram shows a symbol for a component that may be used in an electrical circuit. What is this? So it is actually a buzzer. How do I know? You guys need to check the syllabus component. Let me show you guys. Let me show you. Yeah, I do have the syllabus over here. These are all the circuit symbols that you have to have memorized. Okay, so you guys know what a cell looks like. This is a battery power supply. So if you have a wave over here, it represents an AC power supply. This is a junction, lamp, fixed resistor, variable resistor, or rheostat. This is a thermistor, LDR. This is a heater. This is a galvanometer, voltmeter, ammeter. This is a generator. This is a motor. This is a loudspeaker. Okay, you can easily identify it with this symbol. This is a microphone. This is a buzzer, and this is an electrical bell. So electric bell. The buzzer and electric bell may be confused, so you need to know it properly. The buzzer has the dome pointing outwards. I mean the electric bell has the dome pointing outwards. It looks like a mushroom. And the buzzer has the dome pointing down. Okay, and this is the switch. So make sure you know these. Hopefully that's fine with you guys. You need to memorize these. Okay, and these are the extra ones. LED, just a diode, potentiometer. This is an oscilloscope, and this is a capacitor. So yeah, we had to identify this. The buzzer has the dome pointing down. So the buzzer has the dome pointing down. Okay, so if it was like this, it would have been an electric bell. The loudspeaker is something like this, and the microphone is something like this. Okay, wait, let me see the loudspeaker again. Yeah, it's fine. Okay guys, great. So Kirchhoff's laws, the sum of current entering a junction equals to sum of current leaving the junction. That's the first law, and it follows the conservation of charge. Sum of EMF around the loop is equal to sum of PD across the loop. Okay, that's great. A is the correct answer. You guys know this from paper 2 content. (38) A potential divider circuit is formed by connecting a battery of negligible internal resistance. This is a common question, by the way. The variable resistors have resistances Rx and Ry. Vx is the potential difference PD across the variable resistor with resistance X grade. Rx and Ry are both charged at the same time. Which combination of changes must cause Vx to increase? Okay, so I want this to increase. Remember, according to potential divider, the one who has the greater resistance will get the more voltage. So I want Rx to increase and Ry to decrease. Rx to increase, Ry to decrease. It must be this. 38 should be B, since I want Vx to increase. Okay. Finally, nuclear physics. An actinium nucleus has a nuclear number of 227 and proton number of 89. Okay, so actinium, let me label it as AC, 227 and 89. It decays to form radium by emitting a beta minus particle and an alpha particle in the process. What are the nucleon and proton numbers of the radium nucleus? Okay, so after the beta minus decay, what happens? We end up with something, maybe X. So the nucleon number remains conserved, but due to the beta minus particle, the proton number increases by 1. Okay. Then, to become radium, what it does is it releases an alpha particle, 42. So this should turn into 88, and this becomes 223, 223 and 88. So yeah, I'm gonna go with 39B. Okay. You could do it either way, by the way, alpha first, then beta. It doesn't matter. Which statement is not correct? A meson consists of 3 quarks. This is wrong. A meson consists of 2 quarks, a quark and an antiquark. A baryon consists of 3 quarks. Okay, that's why A is wrong. A proton is a baryon. Yes. Mesons and baryons are parts of hadrons. Hadrons are made up of quarks. Okay, they can either be mesons or baryons. Baryons have 3 quarks. These have 2, one normal and one anti. A quark is a fundamental particle, and there are 6 flavors. Yes. Up, down, top, bottom, strange, and charm. Okay guys, hope you liked the video. If you did like the video, remember to subscribe to the channel down here, and I'm gonna link the playlist for paper 1 up here, and the video for May-June 2022 paper 1-1 up here, and the paper for May-June 2022 1-2 down here. And good luck for your exam coming in 2 weeks, and subscribe to the channel for more content. See you guys. Bye.